Hi all. See this particular problem of area, right? Area bounded by the two curves, right? Came in the year 2020 main paper, right? Now what it says that we are having a region R which is bounded by the two curves. One is y equal to 2x and y equal to x square, right? So therefore, we can start with that problem that in this case that R is the region bounded by y is equal to 2x, y is equal to x square, and that's it. So let's go ahead and try to understand that what is the plot of y equal to 2x and y equal to x square, right? Let's go ahead. So therefore, if I trying to sketch it, right, this is obviously y equal to 2x, that will be some straight line, and y is equal to x square be a part of a parabola. So they will intersect, right? So let's find out the point of intersection, whatever we are going to find out here, right? Let's go ahead. So therefore, we'll say that for point of intersection, we just consider that x square is equal to 2x. That's imply that x multiplied by x minus 2 is equal to 0. That's imply that x is equal to 0 and x is equal to 2. Therefore, corresponding y value is 0 and 2 plus 2, that's 4. So therefore, we'll say that point of intersection it's all about 0, 0 and 2, 4. So therefore, in this figure, we know that this point is actually the coordinate is 2, 4. So this is actually bounded by this line y is equal to 4. This is actually x is equal to 2. And this is the required region R. That's it. Now it says that we are having a line y equal to alpha. That means it's definitely parallel to x-axis, right? So that gives me that y is equal to alpha. It divides the region into two parts. So therefore, we find that what is the value of alpha, right? That's our required point. So obviously, the equation is given. So whatever we're trying to draw in a random graph and all, now let's see that in a proper plots, right? So here we use some plotting tool to get that beautiful plot, right? So whatever we understand that it is bounded by these lines and equations we already know. So let's substitute that condition. So this is obviously y is equal to alpha. This is y is equal to 4. This is y is equal to 0. These two curves we need to find out. Now see that here it says that y equal to alpha divides into region, right? So first we need to calculate the total region, right? The total area, right? Let's find out the total area, right? So the total area. That's equal to integration of, right? Now we can find out in two ways, right? But as it is divided by y equal to alpha, so therefore you can see that it is bounded by y equal to 0, y equal to 4 and right curve and the left curve, right? So what is the right curve? That's we need to write down x is a function of y, right? So therefore you can write it is x is equal to square root of y and the next curve is x is equal to y by 2. So therefore, the integration will be y is equal to 0 to y is equal to 4. My rightmost curve is root y and leftmost curve is actually y by 2. So that gives me the total area with respect to dy. Let's calculate that. So therefore, it gives me that y to the power 3 by 2 divided by 3 by 2 minus y square divided by 4. The limit is 0 to 4. That's it. So that completes the integration. Now obviously we need to find out this value of the definite integration. So let's calculate that. So 0 gone. So therefore we'll calculate it as 2 by 3, 4, 3 to the power 2 minus 4 square. So 4 square is equal to 16, 16 and 8. So that's minus 4. That's it. So that gives me that's equal to 2 by 3, 2 square whole cube minus 4. That gives me 2 by 3 multiplied by 8 minus 4. So it's 16 by 3 minus 4. That's 12, 4 by 3. So the total area bounded by these curves are actually given, calculated as 4 by 3. Now we are trying to find out the region bounded between this y equal to 0 and y equal to alpha, right? So therefore we'll say that let A be the region between y is equal to 0 and y is equal to alpha. Therefore, that area A will be equal to 0 to alpha, the same functions it will be. So, therefore, square root of y minus y by 2 and operating on dy. So, if I calculate, we'll get that. So, therefore, we can write it as 2 by 3 alpha to the power 3 by 2 minus 1 by 4 alpha square. Here, we don't need to calculate that value because see that the integration is already done. So here it is 0 to alpha, okay, 0 to alpha. So therefore, 2 by 3 alpha to the power 3 by 2, 1 by 4 alpha square. Now what is given? It's given that this A is equal to 1 by 2 of that region, right, total region. So therefore, by the given condition, I can consider the total region as R. So the given that A is equal to 1 by 2 times of R. That's imply that 2 by 3 alpha to the power 3 by 2 minus 1 by 4 alpha square is equal to 1 by 2 into 4 by 3. That gives me 2 by 3. So let's multiply by 12, the LCM. So if I multiply it by 12, we can see that this gives me as 12, 4, 8. 8 alpha to the power 3 by 2 minus 12, so minus 3 alpha square. It's equal to 12, 4, 8. That's it. So therefore, we can see that 3 alpha square minus 8 alpha 3 by 2 plus 8, and that's equal to 0. So therefore, for this problem, we can easily obtain that option B is the right choice. And that's it. Hope you understood the problem. Thank you.